Okay, so in this problem, we're shown a graph of some kind of a function, and we want to figure out basically what's the equation of this function. And another way of saying that is there's a parent function out there somewhere, and I'll just draw that in dotted black, right? I think this parent function is probably a square root function. If you guys remember what this thing looks like, it looks something like that. And we want to know how it got turned into this blue thing. So here's the question that we're asking in math words. What happened? What happened to turn our nice regular square root of x into this mess? So let's talk about what happened, and then we can turn those words into the equation that we're looking for. And this shouldn't take too long. If this is my square root function, I can see that it got kind of flipped around, right? Give me my pen. We got flipped around the y-axis here. That is a horizontal reflection across the y-axis. So we know that we've got a horizontal reflection. What else happens? Well, it didn't flip vertically, right? If I flip this thing around, you see, that's kind of what it looks like. But it did not turn upside down too. So there's no vertical reflection. That's nice. What else is going on here? Well, it looks like my function got kind of stretched because remember the original square root function looks something like this. It's rather flat. And this one is very tall, this one that I have here in blue. So I'll bet there's a vertical stretch going on. And if we count grid lines, we can figure out what the factor was. If you look at the original parent function, it's over 1, up 1. Over 1, up 1, like that. Well, what is this here in blue? This is over 1 and up 3. So that is a factor of 3 right there. And I want my parent function back there. So what else is going on? We've got a vertical stretch, no vertical reflection. No vertical reflection. Let's just write that down because that's such good news. And what else? I have some shifts going on. We have a starting point here of the parent function, but the starting point of the transformed function is shifted. And you can see what the shift is. That's going to be, I'll write this in green. Let's put that there. This is going to be a vertical shift up by 2 and a horizontal shift right by 1. Okay, so now our job is to turn these words into an equation. So let's start working through that. Let's take these words and equationify them. So let's just start off with a regular old square root of x. Well, there's a vertical stretch of 3. So that goes right here, outside the parentheses, or outside the square root sign. And we're shifting, let's not do shifts yet. Let's do that horizontal reflection. Okay, that's going to be a negative sign, like this, negative x. And now there's no vertical reflection, so I'm done with all the stuff that has to happen first. Now I can move on to the shifts. And we have an up shift by 2. That's very easy. But we also have a shift to the right. And that means I'm going to have to replace x with x minus 1. Okay, and that's our equation. So it really wasn't so bad. 3 times the square root of negative x minus 1 with a plus 2 on the outside of the square root sign. And again, if you wanted, you could have written this as square root of negative x plus 1, or anything that's equivalent, really. The important part of this equation is if you're dealing with a horizontal reflection, and that's an if, because some of these problems don't have a horizontal reflection. If you've got a horizontal reflection, you have to remember that is a minus sign inside the square root sign, and it's got to go outside this parentheses right here.